Welcome back to the channel. I'm just trying to quickly squeeze the revision of the theory for grade 10 to 11 as far as analytical geometry is concerned. So let's just get straight into that. These are the things that you need to actually remind yourself of if you're going to be proceeding with analytical geometry for grade 12, because no one is really going to be teaching these things in grade 12. So just a quick reminder. Analytical geometry for grade 10 to 11 was mainly based on just 2 points, A and B, of which each point has its coordinates like XA, YA, and then B has its own coordinates, which is XB and YB, like that. So those 2 points, just like any other point that you can think of, you can calculate the length between those 2 points. How do you do that? You use the length formula. Some they call it the distance formula. So you could either call this the distance between A and B, the length of AB, or the distance between A and B. So whichever one you prefer, or the person who's asking the question prefers, they are basically just asking for the same thing. So you still use this formula, and then you just need to substitute the coordinates of the 2 points. We're not saying it only works for A and B. Even if it's C and D, or D and F, or Z and K, this formula still works. You just need to know the coordinates of the 2 points that you need to substitute into the formula. Sometimes they give you the distance and then they require to get the coordinate or one of the coordinates. So you just need to substitute on the same formula and then look for the unknown variable. That will be okay. And then number 2, you need to know the midpoint formula and how to apply it. Midpoint, basically, when you have 2 points like this, A and B, is just a point which is exactly at the middle of A and B. That therefore means the distance between that point, which is usually given by the big letter M, the midpoint, the distance between A and M, it's equal to the distance between M and B. That is the midpoint formula, and the formula is given as such. So there's no need for me to rewrite that. As for the gradient between A and B, the gradient can either be positive or negative. You just need to substitute here properly, and then you will see the outcome if it's positive or negative. If it's positive, it means the line is slanted to the right. If it's negative, it means the line is slanted to the left, like that. This is for the negative, this is for the positive gradient. So that's basically it. And then for each line, whether or not it's slanted to the right or to the left, you can be able to calculate the angle of inclination of that line. By the angle of inclination, they just mean this angle from the positive x-axis to the line itself. This angle is theta. Again, for the negative gradient, the line is from the positive x-axis to the line itself. It's also given by theta. So in the case where m is positive, you just need to take tan or theta equals to m to be able to calculate the angle of inclination. Therefore, theta, which is the angle of inclination, equals to arctan of m. For the case where m is actually negative, you need to first try to get the reference angle, which is this angle, right? So to get the reference angle, you still just say tan of the reference angle equals to that negative gradient that you would be having there. So the reference angle, you can then get it by, I hope you can see this, just arctan of negative m. Then now to get the angle of inclination, which is what you'll be trying to get when you're doing all this calculation. So to get that, is just theta equals to 180 degrees minus the absolute value of the reference angle. So this will give you a reference angle in degrees. Now you just need to substitute its absolute value here, and then you'll be able to get your reference angle. I hope that is clear. Okay, and sometimes you need to deal with 2 or more lines. When dealing with 2 or more lines, you need to be reminded or remember that the lines, if they are non-vertical lines which are parallel, then their gradients are actually equal. For non-vertical lines which are parallel, their gradients are equal. And for the very same non-vertical lines, or not necessarily the same, but non-vertical lines which are perpendicular to each other, the product of their gradients is actually equals to -1. And then we are disregarding the non-vertical lines because the vertical lines they have an undefined gradient, so that is why they are being disregarded here. Okay, and for C, we could be having points A, B, and C which are said to be collinear. By collinear, there's nothing fancy about that term. It just means that point A, B, and C, in that order, they happen to be on the same straight line. That's what collinear means. Just saying that you have the points A, B, and C, they are lying on the same straight line. As a result, the gradient of AB is equals to the gradient of BC, and that is also equal to the gradient of AC. That's basically it. So that can help you solve some of the questions if they say something about collinear. Okay, and also we need to be able to derive the equation of the straight line. There's just two formats that you can use, this format and that format. The first one is the standard format of a straight line. So ultimately you are required to have your equation of a straight line as y equals to mx plus c in this standard format. However, sometimes it's just quicker to use, or easier to use a standard format of the second one, so that you can substitute, because maybe you have a given point which is on the straight line as well as the gradient of that straight line. So you can just substitute there and work it backwards to come back to this standard form, right? Ultimately, just leave it in this standard form. Don't leave it like this. Don't just substitute a point and then leave it there. You need to just simplify and then get back to the actual standard form of a linear or a straight line. Okay, for a vertical line, the equation of the straight line is just given by x equals to a certain number. For a horizontal line, the equation is given by y equals to a certain number, and for the horizontal line, the gradient is 0. For vertical line, like I said, the gradient is still undefined. Okay, this is basically the content that you needed to remember. And then in the standard equation, c is just the y-intercept. Remember, m is still the gradient, and then y1 x1 is just a point which is on the line. So we'll be doing a couple of examples using this in the next videos. I hope this video now it has audio and there are no problems. Then we will see you in the next video. Thank you.